that in HCG 2.0 use DCN as the primary networking provider. We should have a session on it, and we can run through the common constructs. So the first difficulty that I had when I was going through the DCN part was, so there are a set of constructs in DCN, and then there are a set of constructs in OpenStack, right? So you have provider networks, you have floating IPs, you have subnets, you have all of that inside of regular OpenStack, and we've been using that, and all of us are comfortable with that. But then there are a whole new set of constructs inside DCN, like zones, subnets, and domains and things like that, which are pretty new to all of us. So I think the first thing that we need to do is map each one of those constructs with the ones that we know, so that when tomorrow when someone asks us for a use case wherein you have to say create a provider network, how would you do that inside of DCN? So this part that I just talked about would we'll just cover it right at the end actually, wherein I just have a informal set of topics, and I have a set of topics listed, and we can go through each one of them. Before that, I thought since most of us are new to DCN, I thought we should just do a small overview of what the solution entails. I've picked up a regular deck and tried to cut out as much as marketing material as possible. So if you still think something is not relevant, I think we can move forward pretty quickly. So DCN stands for Distributed Cloud Networking, if you didn't know that already. So essentially you'll keep seeing these three terms on and off, and these three terms, that is VSD, VSC, and VRS, form the basis of the solution. So if someone asks you what solution you are using, it's called DCN, which actually is HP has OEM'd a product called Nuage VSP. So Nuage is the name of the company. VSP, which is Virtualized Services Platform, is the product that we have called DCN. Okay, so VSP is the overall product, which is called DCN, in which there are three different subcomponents which form the basis of the solution. So you have VSD, you have VSC, and you have VRS. So VSD stands for Services Directory, VSC is the controller, and VRS is what sits in individual compute nodes. So if you're familiar with any of any SDN solution, right? So the first thing that you have is you have some kind of a UI or some kind of a policy engine wherein you can go in and push in a policy. To implement that policy, you have a controller which is actually going in and pushing in the policy to the end boxes or to your switches, and then you have the actual switch itself, which is acting as the forwarding plane. So I did a presentation on SDN quite some time ago, and then if anyone had a chance to go through that, what you would see is that you have a separation of entities, right? So the whole premise of SDN is that you have a switch which is no longer intelligent. You have the controller, which is actually the intelligent piece, which is trying to push in policies to the switch, and you can push in a number of switches that way, and then automate the whole configuration and orchestrate it via the controller. That is the premise of SDN. Now, so the Nuage VSP platform, or DCN today, is actually based on a similar premise, wherein you have something called as a VSD, which is the policy engine, wherein VSD would form the basis for you to do all of your operations. You would not really see the other two parts listed here. So VSC and VRS are something that you would deploy first time and then leave it at that. What you would actually be dealing with is the VSD itself. So VSD would be the GUI wherein you actually go in and do all of your policy definitions. You would go and create network subnets, zones, and all of that. So I'll run through each of those things, but then to give you a high-level picture, the GUI is the VSD, and then the other two components are basically deployed once, and then you'll have to go and deal with them only on an absolute need basis. So the VSD actually exposes a GUI. It also exposes a REST API, which can be consumed by any cloud management platform. So can be HP Xelium OpenStack, it can be CloudStack, VMware, and so on. So anyone who can call a REST API can essentially go in and create a network subnet and all that. And then, so the advantage that DCN comes in with today is that so if you look at regular OpenStack, right? So what do you get? You essentially get a set of hypervisors wherein you can go and perform virtual networking operations. So if you have to integrate a third-party gateway or a physical gateway or a physical switch or something like that, right now the technology is not really mature, right? So if you want to say program a switch, sure there are things like Cumulus networks which are coming up with plugins where you can actually go and program a physical switch as well. But then your entire focus is based on virtual networking. That is, you can create virtual routers, virtual load balancers, virtual firewalls, virtual subnets, ports, and all of that. For you to integrate, existing data center networks or existing data center networking equipment, that is something which is not, really present inside of OpenStack. So what DCN gives you is the ability to integrate third-party bare metal software and gateways, as well as integrating with your existing hypervisors like VMware, and Hyper-V, KVM, and things like that. And the way that you would do it is really transparent in the sense that you would not need anything specialized for you to talk to a virtual, piece of software or a gateway or a router like that. So. And that's what they're saying, that you can have any IP fabric and any gateway. That's, you can have a 5930, you can have a 7900, which is Alcatel-Lucent's own this thing, or you can have a hypervisor like a Zen or a VMware. So that's just to give you an introduction. And this is a little more of a deep down view. So what you have on top is the VSD, and you have OpenStack and all of that talking together. Now, so the one. Okay, so why did we choose, DCN as part of our carrier grade or our HOS offerings, right? So, with DCN, you have the ability to talk across data centers as well. So, in that sense, it's a pure overlay solution. So, all of your VRSs that you see, which are actually, a modification of Open vSwitch, which is residing on, each of these hypervisors there. Each VRS actually talks to VXLAN. So what you have essentially is that you can have DCN sitting in multiple data centers, and you can have an overlay solution between all of those. And that essentially gives you a solution with which you can deploy OpenStack in multiple data center here and then a data center somewhere else, and you can have a common set of VLANs and VXLANs and things like that. So those of you who have worked with us on context stream opportunities would know that you can have a VXLAN based solution wherein you would have an underlay, and you can actually have L2 over L3, right? So this is a similar thing, but in fact has a much richer set of features to it. So how is it achieved? Essentially, they use BGP, which is a dynamic routing protocol, wherein you can have one single policy engine, right? So think of the VSD as a centralized policy engine, and then per data center you can have say one VSC. So you have one So say you have two data centers or you have three data centers. You have one place wherein you have your VSD. In each of these locations you have a VSC, right? And then per hypervisor you have a VRS. So those three components are divided that way. You have a VRS per hypervisor. You have a VSC or a set of VSCs per data center, and you have a centralized VSC. Okay. VSD, yeah. So you have a centralized VSD. Now, so your VSD can actually push in your policy to all of the locations and push in policy so that your VSC can implement it, and your VRS is actually sitting on each of the hypervisors. So this is the high-level view. Now, if you have to look at how your VSCs are talking to each other. Now, if you want to have connectivity between data center, two different data centers, then the least that you need to have is that you should have one single person who's actually doing the policy, or there's a policy which is actually shared across all of your data centers. So if you have a network in one data center, and they have to, and and you need to have a VM on the same network in another data center, then there needs to be some level of awareness between the actual controllers. So that is happening via MPBGP, which is multi-protocol BGP, which is actually over a VPN. So, so the way it talks is that your VSC talks to your edge router, and then your edge router is actually connected by an underlay, and all of your VSCs are then communicating via BGP, and then you have a higher level policy which is being pushed via VSD.
So in the VSD, is there any view of the VRS at all, or you only see VSD?
So you see VSCs, and so do you see VRSs as well? You see VRSs as well. Okay. So you see individual VRSs and VSCs as well.
So the communication of VM will be through VSC, like this VM of one site will communicate to other VM of other site. VSC,
no. So
why VSC needs communication?
Yeah. So so your VSC needs communication because what happens is if you have a forwarding information base, right, your FIB, which needs to pass across data centers, that actual FIB is being shared by your VSC to the other VSC, so that VSC can then push it down to its individual VRSs. So so a VRS in one data center cannot actually communicate with a VRS of the other data center directly, right? It has to go via the VSC if it has to share information.
Then in that case, VSD can also do the same thing because it is common to all the VSDs. So anyhow, we are pushing all the FIB and policies from VSD to VSD.
No, so your route sharing and your information sharing is happening via the VSC. So the VSC has information about which place to go when you have a particular VM or a particular IP or something like that, right? And then when you have to look for a policy for a newly come up VM, for example, when there's a VM which is coming up and you have to get information about what kind of policies that need to apply for this VM, that is when the VSD comes into picture. So the VSD talks to the VSD, gets the policy, and then pushes the policy onto your VRS. But then for every other communication wherein you have to share information, it's actually happening via the VSD.
So VSD is directly connected with the one VSD is connected with the other VSD, or they are connected through VSD only?
So the VSD is the centralized view, and through your VSC you will be able to talk to all of your data centers.
No, but all the traffic will go through VSD only, no? Because VSC is also connected with each other.
Yeah, so the VSCs are all connected to each other. So your VSD is just pushing in the policy. Your VSC is the one that is talking to each other via BGP.
BGP will be by default configured.
Yeah.
There is some network that is dedicated for that, or
so your underlay has to be present for you to talk to your edge router.
So we have to ask from the customer, like, I need this network as well.
Edge router is per site.
Yeah. So you'll have one edge router or a set of edge routers per site, which forms the underlay, and you have to talk to the edge router via BGP, and then there's a relay of.
So like these are like 3 data centers, and they are connected with VSC, and they are connected. So this connection is also there.
Yes. So that's what this shows, right? You have this is a set of VSCs. All of your VSCs are talking via
MPBGP.
Between the edge routers, what would it be?
So your edge router signifies that you have reached the edge of your site. So from then on, you have your underlay. That is a physical connection that is there. So for example, if you have to go from, say, Salatpuria to Electronic City, you would in all probability have an edge router in this site and will have an edge router on the other side. So for internal routing, you might most probably have ISIS or OSPF. But if it's an exterior routing, it's going to be. So you would have an underlay between these two sites. However, I mean, it might go to an ISP and all of that. But for you to share routes between two different sites,
So, Adi, a question. So the VRS or the routers are the only ones which are connected between the data centers, right? The VSD and the VSC. Is that right?
your voice got scrambled, Sudhi.
Hey, the question is the VSD and the VSC are actually confined to the data center, and only the VRS gateway talk across the data center. Is that right?
No, so your VRSG is basically, think of your VRSG as a hardware VTEP, right? That is the one which is used to talk to any kind of physical equipment that you have. So, for example, if you have a 5930, or if you have, any other, say you have a provider VLAN that you have to talk to.
Mm-hmm.
So you would use your VRSG to talk to your provider VLANs, and you would use your VRSG to talk to other physical equipment which is there in your data center. Your VSC is actually the controller which is talking to its other peers. Now these other peers might be in different data centers as well.
Okay.
So if you look at the PPT that I presented, right, there's a hardware gateway for bare metal. Example 5930.
Mm-hmm.
Right, so that could potentially be replaced by a VRSG. And you could use your VRSG to talk to other physical equipment or physical switches or gateways that you have in your data center.
Basically, if you want to get out of that VXLAN boundary.
Correct. So your VRSG is the one which is doing VXLAN to VLAN translation. And we actually saw the OpenFlow rules which are doing that as well.
This OSPF, what there?
So there are two kinds of routing protocols. I'm not the expert. Mukul knows more than me. But OSPF and ISIS. So OSPF and ISIS are generally interior routing protocols. So if you have a smaller area, or if you have a smaller set of elements, in all likelihood you would be using OSPF or ISIS. If you want to do it, so BGP is a more complex, and it's a more for a larger area, and it's used for exterior routing. So you would use OSPF. So like I gave an example.
HP to Infosys, they are not. HP is part of one provider. Infosys is part of other provider. And still, if they want to exchange some route, like from here you are trying to access Infosys, there can be a chance like you have a hardware running here, and they are accessing from there. So there should be an exchange of routes from this to that. So normally we will say autonomous system. So HP is part of one autonomous system, and Infosys is part of other autonomous system. When they want to exchange a route, we will use BGP. This is exterior gateway routing, where one network and other autonomous system wants to communicate. But inside HP only we have many networks. They also have a route exchange. This is done by interior protocol known as OSPF or ISIS or interior BGP. BGP can be interior as well as external.
IBGP and TBGP.
This is from one side to other side.
Okay, so I just thought I'll put that across. I already talked about the consistent networking part, wherein if you have to talk to bare metal or you have to talk to any kind of virtualization technologies, you would use the same interface. You really do not have to go to different kinds of plugins or whatever that is to talk to different sets of software versions or hardware versions. So then they talk about performance and scale and security and all that.
Yeah. VRS is present on each compute node.
Yeah.
It's compute node wise.
Yeah. So VRS is a fork of fork of Open vSwitch. Fork of Open. I mean, think of it as an implementation of Open vSwitch. So and it's open. So you can run your regular OFCTL and DPCTL and all of those commands on that.
Okay, so this VRS is connected with VRG.
VRS is not connected to VR. So VRS is a software VTEP. VRSG is a hardware VTEP. All of these are connected to your VSC.
Okay, so this one is also connected to VSC. This VRG is connected with VRSG.
VRSG is actually a hardware VTEP.
Yes.
Okay, so that is connected to your VSC. VRS is a software VTEP.
Okay.
which is also connected to your VSC. So all of them get
So they
policies.
are not directly connected with each other, compute one and this.
No. Everything is via the VSC itself. I mean, see, directly connected in the sense that, see, once your VRS has all of the policies, and if you want to have a VM which is sitting on compute node 1, you have another VM which is sitting on compute node 2, right? There would be a wasteland tunnel between both of them. So in that sense, it is directly connected as well. But then there's no, physically they are not connected.
EVS was also open vSwitch implementation.
No, AVS was not open vSwitch. AVS was not open at all. It was a closed WinRiver implementation.
Closed, but it was
AVS is not OVS. That's what the lab always told.
No, it was not OpenFlow compliant as well.
AVS is network.
yeah,
WinRiver's own implementation.
It was not even OpenFlow compliant.
totally from
I mean, the whole challenge with AVS was that you couldn't hook up OpenDaylight to it, for example. Because there's no way OpenDaylight can talk or can be a manager of this OpenVSwitch. I mean, we'll talk about it a little later as well, wherein we'll show you how and
Any
Avinash can
SDN
pitch in
controller
as well.
can't communicate. All SDN controller can't.
Yeah, anything which is OpenFlow compliant cannot communicate with it, essentially. Okay, so I want to talk a little bit about the security part. So micro-segmentation has been an ask from a lot of customers. In fact, in the Singtel case, we were showing them security groups, and we were basically, asked that they actually want micro-segmentation and not security groups. So what is micro-segmentation, right? So DCN gives you the ability to put in security policies, including ingress, egress policies, to a very, very fine-grained level. So security groups actually apply per port, right? You could have a one rule for port 80 on a neutron port, but there was nothing at a zone level or a subnet level or a router level or anything like that. So micro-segmentation basically lets you define security policies at various levels of your network hierarchy, right? So you could do it at your router level, you could do it at your zone level, you could do it at your subnet level, and an individual port as well. So what this gives you is the ability to, essentially create a hierarchy of ACLs, and you can give something like, think of it as an OpenFlow table, right? You have a set of rules, and all of the rules are traversed in an order. Similarly, you can have a set of security policies as well. Wherein the first policy is hit, then the next policy is hit, and then the third policy is hit. So this is called micro-segmentation, wherein you could essentially have a set of policies defined, and it can be extremely fine-grained. Now, the one other thing that this helps you give is something is actually for the service chaining use case, which we have been looking at. Imagine if you have a situation wherein you have a firewall and you have a 3-tier application, right? You have a firewall in the beginning, and then you have a web app and a DB. You want everything which is destined towards the web layer to actually first go to the firewall and then come there, right? Because you have to filter traffic and you have to find out if everything is okay. And then in between the web app DB as well, say for the app layer you have a load balancer, right? So that would mean that whatever traffic is going from the web layer would first have to go to the load balancer, and then the load balancer would decide where to, which app server to send to. So this is a classic service chaining use case, right? So traffic has to first go to the firewall, get redirected to the web, get redirected to the load balancer, and then get redirected to the app server. So in this case, the web app and the DB servers are actually not aware of the firewall and the load balancer. So there are no explicit rules in the web server or the load balancer to say that once traffic comes in, send it to the firewall, or once traffic comes in, send it to the load balancer, or anything like that. Web app DB servers are implemented as the way that they are implemented. They are not aware of the higher level networking devices or software that is there in between. So DCN lets you do something called as the redirection of traffic, wherein you could say that all traffic which is going into this subnet, say say you have your web subnet, you can say all traffic which is going into this web subnet, first redirect to this guy, and then the firewall takes care of whether it is to allow or to reject traffic and so on. So you could define policies like this, which is what we are seeing in Star Hub as well, wherein we have a firewall and a load balancer, and we are supposed to do service chaining. This wouldn't have been possible with at least Kilo of OpenStack. So as an update, Mitaka is coming up with a service chaining API, at least for the next 2 versions.
So you basically set up this policy in the VSD. VSD takes care of, so VSD is supposed to enforce these policies on the network itself, right?
Yeah, so the VSD basically has a policy definition. VSC is the one which is responsible for pushing it to the end hypervisor, to the VRS. So essentially what happens is, say I have 2 VMs, and those 2 VMs are on 2 different compute nodes. When my packet leaves the first VM, it then goes to the VRS of that same compute node. So the VRS applies whatever security policies that it has to apply. So it will apply ingress policies there, and then it sends there is a VXLAN tunnel to the other VRS. So it goes there. That VRS applies egress security policies or redirect policies or whatever that is. Then it sends to the end.
So basically, whatever is destined for this web app, when it comes to the VRS, it will be sent to the firewall indirectly.
Yeah.
But we have seen in SDN case also, won't this take up a lot of time and isn't it a overburden to every time do it, or is it cached somewhere so that it can be?
See, the rule itself is an open flow rule, right? So there's actually not much of an overhead in. We've seen context teams, right? They put in 1 billion rules and they're getting.
For example, this could be a typical case for some DPI solution to be put in between. From your web tier, it has to go to the DPI. Once everything is clear, then it comes to your web server or to the load balancer directly. It distributes it to their number of web servers.
It seems like a rule is an overhead, but then we've looked at context teams. Billion rules is what they're talking about. So that's the only reason I put this slide in here. Okay, so let's go to the slightly more deeper technical stuff.
If I were to trace that packet, I will see all those additional hops in there, right?
If you would trace the packet, I don't know what the output of tracer out would be. I don't think so as well.
Rule you are giving maximum.
You cannot see that.
You will see star.
Yeah, I don't think you will see anything.
You will not see the IP address. It took 4 hops to reach the destination. That only thing you can.
If you go on to the VRS itself and then look at the rules, you will see hits and you will see
So this VRS, each individual VRS content of what rules it has, can be seen from the VSD?
No. VRS is an open switch.
So
you can go there and do OVS over
normal
CTL, dump flows, and you will get the list of all the flows.
So you have to always do that. You cannot see that in a GUI where you can edit.
No, you can see the security rules, the ingress rules, the policies that you are applying. But the individual rules, the individual open flow rules is something you cannot. So there's one other part that I missed here. So
no, actually I was coming from an angle that suppose for example in the OpenP switch you can actually go ahead and change the route or do something like that.
You can. You can push in rules. You can push in rules if you want to.
Okay, but not through VSD, directly.
Yeah. I mean, if you want to add a rule, you can always do that. So that basically reminds me that I've missed the communication protocol between each of these layers. So your VSD talks to your VSC via a messaging protocol called XMPP. And then your VSC talks to each of your VRS by a protocol called OpenFlow. So that thought was...
VSC talks to VRS by OpenFlow.
That is a regular how even Neutron talks, right? So this slide is basically sort of a mantra for us till we gain more familiarity. So the terms that you see in the middle, right, policy to domain zone enterprise, something we haven't seen before. And the left-hand side terms are the ones that we are extremely familiar with. So I'm also going to explain how to create a policy group and how to create a domain and so on and so on. There has been some controversy about how to achieve this, whether it has to be directly via OpenStack or whether it has to be via the BSD and then so
security groups from OpenStack makes no sense.
Yeah, so okay. So I was debating when I would bring up this point, but the thing is, you see all of these constructs, right? So the VSD has zones, subnets, all of that, and then you have OpenStack, which is giving you only network subnets, routers, and so on, right? Now, if you have an integration with Nuage, what does it mean? It basically means that if Nuage is acting as an ML2 plugin, I should be able to go and do, and if this is the mapping that I have, I should be able to go and create a domain, I should be able to go and create a router inside OpenStack, and a domain should get created in VSD. Right? That's the point of an integration, correct? And if Nuage is an ML2 plugin, then and it has this mapping, that's the rule that it should follow. So there has been some debate. We have a call tomorrow as well. But then, the reality is not that. What is the reality today? So the reality is that, okay, if I step back one more point, Nuage by itself has published a set of Neutron API for us to consume, right? So there's a set of pretty rich Nuage, Neutron API. So for example, there is, so all the operations that you would do, and Avinash has done this multiple times. So there's a set of operations that you can do on the gateways, right? You can allow VLANs, and if you want to add more VLANs that you want, then you can just go, you have to go to the gateway and add more VLANs, right? Now, this is an operation which can ideally be done for Neutron itself. So there's a command called, Neutron Nuage gateway port show, port list, port create, VLAN allow, and so on. So it's a pretty rich set of API which is missing in HCG 2.0. Right? So we've raised this to the account team, to the PLM, and we've asked them why, when the kilo plugin of Nuage exposes a set of API, that API is missing inside of HCG when HCG 2.0 is kilo based. Right? So why did I bring this up? Essentially, even though Nuage has Neutron API, Nuage, and ideally you would have to go to Neutron and then create a router. It should get reflected into VSD. That's not happening today. Every operation that you would have to do in VSD, every operation that you have to do in Neutron today first has to be done in VSD. So if you have to create a network, you have to go into VSD, create a subnet, create a zone, create all of that, and then go to Neutron and then do whatever operations that you have to do. Today it's a two-pronged, two-step operation. Right? So
what if they're not in sync?
Exactly. So it is up to us to actually go in and So it's a pretty primitive way of doing things. And we have a call tomorrow to figure out why that is.
In the way now it is there that you create in VSD a network, for example, you use that UID to create something. Now if I delete this construct which was right now created in Neutron, that be reflected back in PSD or it will remain as it is?
So there is no correspondence between Neutron and basically whatever you do in Neutron is just referencing an
So basically the orchestrator not only has to do two steps every time, it has to keep track of what it did to something.
Ports, deletion of ports, deletion of VMs gets reflected. But network objects are not yet.
Okay. The same applies for security group.
Yeah, the same applies for everything. Except VM's port, everything is.
Basically these products are not integrated yet.
Yeah, it almost seems like there's no integration at all.
they are existing in two separate planes. There are some communication. There is absolutely no communication that
Yeah,
you are doing on
there is
behalf of.
communication in the sense that when I create a VM, it's showing up there. That's the extent of it. It's a pretty strange one. I know what the.
Why is the case or is that a typo? Ingress rules becomes egress policy.
Yeah. So I have a slide explaining that as well. So that's also a slightly different from what we would expect. Now, so if I would run through this list. So what you would have to remember is that a domain is sort of your central piece inside of VSD, and a domain corresponds to a router. So I can actually create a domain inside of VSD, attach subnets to it, right? And all of these subnets will be able to talk to each other by referencing the gateway's IP as the default gateway. So a router corresponds to a domain, and then what you have is there is no concept of a network and a subnet separately inside of nuance. It's just a subnet. There's nothing more. So the other important thing that you have to remember is a zone. So the hierarchy is that I have a domain, I have zones. Inside zones, I have subnets. Okay. So a domain is a router. A zone is a collection of subnets, and then I have subnets themselves. Okay. Now, so an example of a zone, right? That can be something like you can have a public zone, you can have a private zone, you can have a web zone, app zone, DB zone, that kind of thing. So when would you create a zone? Essentially, if you have a set of similar sounding or similar group of entities, then you would essentially create a zone. And then you would attach subnets to the zone.
Parista is asking, he is joined the call, but he is not able to see. Can you mute? The network issue, he is not able to join the call.
Okay.
आप मेल कर दो.
अभी कर दूं?
चिल्लाने वापस आ चुके हैं.
Hello?
Yeah, Pradipta, Adi just sent you the PPT.
Yeah. Actually, due to network issue, I'm not able to connect that through link. So please share that PPT so that at least I can see that.
Sure. Anyway, I'm recording it also. I'll share it within the group later.
Okay, fine. Okay.
So the three things that you have to remember: domain, zone, and subnet, and then ports attached to your subnets. So, okay. So the strange one here is.
So the port is called a port.
Yeah, port is a port.
So network that is created using neutron, what would it map to? Nothing. But
Nothing.
so the neutron subnet.
Neutron subnet maps to a subnet inside of. So what you have to do is you have to go in and create a using Neutron you create a network, and then create a subnet. When you're creating the subnet, you take the UUID of the VSD subnet that you've already created, and then put it in your Neutron subnet. There's a parameter called nuagenet. So you put nuagenet and then put the UUID, specify the net partition name. So for OpenStack, what they have done, what Nuage has done is they have included something called as net partition. So a net partition, essentially, think of a net partition as a tenant. So it can be a collection of domain zones, and you could have multiple net partitions, and you can have each time you're creating a subnet, you can actually reference a net partition, in which case it will go to different tenants.
So So whenever we are creating any port from Neutron, it will be reflected in view.
I haven't tested Neutron port.
Once you boot on,
no.
while
booting it works, so I am guessing that if you do a
if you delete that VM, that will go off.
Yeah. So I'm guessing it should come. Tested it out.
Multiple ports are also recognized per VM.
Yeah.
Or only the.
Yeah. So what you will see is I'll have domain, zone, subnet 1, subnet 2. Okay, and I'll have the same VM reference 2 times. So it will not be a VM with 2 legs. It will be two ports. Okay. So why are the ingress and egress policies different here? So you have ingress rules which become egress policies and egress rules which become ingress policies. Yeah. So what is happening here is that for Neutron or for OpenStack, the port is everything, right? You are actually defining rules for traffic which is coming into the port and leaving the port, and hence an ingress rule becomes traffic which is coming into the VM. Egress rules becomes traffic which is leaving the VM. But for Nuage, the network is everything. So traffic which is coming into the network is ingress, and traffic which is leaving the network is egress. So think of a network as, say, a cloud, and you have a host connected to it. Traffic which is coming into that network is essentially ingress. Traffic which is leaving the network, which becomes egress. Traffic has to come to come into the network, come away from the host. Right? That's why it's here.
So there is no use of ingress security group.
Yeah. So
there is no concept of security group for OpenStack. There is no
so,
line switch.
So Nuage is with the Nuage Neutron API. When you would create a security group, it would map automatically to a policy group. So policy group is so there's a concept of a template here, right? So a template, say you have a domain template. So domain template essentially lets you create a set of subnet zones all at once. So for example, if I have a 3-tier application for which I'll need, say, 4 subnets, right, or 5 subnets, and I have 3 zones or 4 zones, and I have a set of policies which specify redirect, ingress, egress, and all that. I could create this as a template, and then keep instantiating the template again and again. And what would happen is each time I would instantiate the template, all of this is created at a single time. I don't need to go in and create individual templates. So within a template, I have the ability to actually go in and create something called as a policy group. The policy group is a set of policies. Now, a security group, which is again a set of policies, would map to a policy group inside of Neutron. But what you would have is, for the additional features that a policy group gives you, for example, redirect, there is no redirect in a security group rules, right? So the redirect security group rules could actually be done via the Nuage API. So the Nuage Neutron API would let you do, Neutron security group rule create, and it would let you tell, that I want redirect and all that. So it actually gave an extension, sadly missing it. Okay. So how is it integrated? Basically, I have I have the Neutron plugin here, which is essentially an ML2 plugin. Now, so just a bit of a background. Subbu and I were at the Vancouver Summit, and we were talking to the Nuage guys. They were at Ice House then. So Nuage was not an ML2 plugin then. Right? It was still a monolithic plugin, which would mean that I cannot have any other plugin, coexist along with Nuage. So that would not allow me to. So that would mean that if I have Nuage, I have nothing else, and I don't have any other thing. So why am I talking about this? Essentially, now they have moved away from that and they have come to an ML2 plugin. So the Neutron plugin that you see here, what I'm pointing to here is actually an ML2 plugin. This allows me to have the SRIOV NIC switch driver as well. Right? So so for SRIOV ports, I'm basically bypassing the VRS, in which case Nuage has no role to play, for which I have the SRIOV NIC switch driver, SRIOV NIC switch plugin. So I have the SRIOV NIC switch plugin, which is used for PCI pass-through and SRIOV, and Nuage is used for VRTIVE. Right? So that is the and this basically talks about VRS is running, and I have the Neutron API. There's nothing here. Okay. So what is the network creation process? So I've talked about this earlier. You basically go in and create a tenant or a domain and all that in BSD. And then what happens next is that so whenever a new VM is created, there's an event which is captured by the VRS. So the VRS basically sends in a notification to the VSC, and the VSC then queries the VSD via XMPP, and then the VSD actually responds with the policy, which then comes into the VSC, and then this VSC talks to all of its adjacent VSCs via MPPG.
And then this will be mapped to the Keystone tenant, like whatever.
No.
There will be separate username password
for Nuage, yeah. So the Keystone tenants have got nothing to do with the.
So if we are creating some network under one tenant of Nuage, then how will we map to OpenStack?
If I'm creating, okay, so the net partition that I've talked about, that is so there's something called as an enterprise inside of Nuage. So an enterprise, essentially think of an enterprise inside Nuage as a tenant. Nothing maps, so in the sense that if I create a tenant inside Keystone, it's got nothing to do with the tenants inside BSD. But there's an enterprise inside of Nuage, which corresponds to a net partition inside of OpenStack. So whatever I want to put under that enterprise, I'll actually put under the net partition. So whenever I'm creating a network, I'll have to specify the net partition, in which case it will come under that enterprise. So if I want two enterprises, then I have to create two net partitions, and whenever I want to create a subnet, I have to reference a net partition, in which case it will go to whichever net partition that I've referenced.
Now if we are doing some POC and so customer will be able to create a network, we have to create it.
Right. It's a pain. It's not ideal. But apparently there are some benefits. So, so remember, this is all VXLAN traffic. So all your tenant networks are all VXLAN based. So whenever you have a VM talking to another VM, so you have a hypervisor here, you have a hypervisor there. They have the same VXLAN ID. There will be a VXLAN tunnel between both of them. If you go into each of those nodes and you actually look at the overflow rules, that's being corroborated there as well. Okay, yeah, so this is the basic mode and the advanced mode that I was talking about. So right now there is no basic mode and advanced mode. The basic mode would mean that everything would happen via OpenStack and it should get reflected up. But if I want advanced features like service chaining and advanced ACL, then so yeah, we are in advanced by default.
Sorry, what is missing in the basic mode compared to advanced mode?
Sudhi, there is no basic mode and advanced mode right now. Essentially, you have the same thing, basic mode and advanced mode. We don't have a basic mode at all. Inside HCG 2.0, at least, there is only one mode, that's the advanced mode. So
documentation talks about them, but
yeah, so the plugin documentation talks about advanced and basic, but then there's nothing reflecting in 2.0. So the difference would be that in the basic mode, if you would go and create a network inside OpenStack, it would automatically get reflected inside Nuage. But if you create a network inside of OpenStack today, there's no way for VSD to know. So everything would have to be first done in VSD for us, and then it would have to be created in OpenStack.
Right.
Okay, so what is the flow? Essentially, first create a DCN domain zone subnet, and then you would create a router network subnet, and then you would create a VSD network object. So the interesting part is from when you actually launch a VM. So when you launch a VM, there's a NOVA call which is made. So NOVA talks to the NOVA compute process, which goes in and creates a VM. When there's a new VM, the VRS takes note of it. It goes and tells the VSC that's here that there's a new VM. What do I do? The VSC then talks to VSD, saying there's a new VM. What do I do? The VSD then pushes a policy, and when the actual VM is started, that is when the policy is reflected. So this part that you see here is being covered by this.
The policy pushing is based on what the user attached that VM to.
No, the policy. So the policy is defined per network, right? So if I'm attached to say a management network and I'm attached to an internal and an external network. Now, for each of these subnets, there would be a policy in all likelihood, saying for this, say for the management this thing there is no policy. For the internal, there is some redirect. For the external, there is some firewall redirect and ingress, egress, and all that. So for each of these, there would be a policy which is being pushed right down in the form of an open flow rule to the VRS. So that whenever a packet is coming in from that NIC, from the management NIC, then you would apply all of the ingress, egress, and redirect policies too.
How will the VRS or VSD know on which network that VM is?
How will the
VRS or VSD?
when a new port is created, it will be on a network, right? So
Subnet is mapped with the Nova's network.
Correct.
So when you create a port, that will be under one subnet. That is mapped to one specific Nova.
So you have to create the port as well?
No. See, when you are creating when you are doing neutron subnet create, that's when you are referencing the Nuage subnet in the subnet create command itself. So what happens is whatever. There'll be a VRS agent which will be looking at any ports that are created, or maybe when a port is created, there would be a message which is passed through. So whenever I do a Nova boot, there's first a neutron port that's created in the subnet. When the subnet is created, when the port is created, it will go get the policy for it. And policies are attached to a subnet, most likely. They can be attached to a zone, they can be attached to anything. But
Create a port in
it's reflecting there. It should, otherwise Nova boot won't. I think.
How does it?
Okay, I had another slide which I deleted, so let me just.
Link is not lost, right?
Okay.
Is there a demo, Adi, that we can look at?
Yeah, I can do a short demo as well. At least the network creation and
Yeah, this flow, basically
policies
this
and
flow.
all that. Yeah, so I just have one last slide where I want to do a little bit of whiteboarding. If we have time, I can run through a small demo as well. Okay. So this is just. Okay, so I wanted to talk about a few more things which would be relevant to us when we are doing all of our POCs. And I already covered neutron nuance net partition. There are a few other things. How would you do provider networks? Last question for us. How would you work with floating IP? Shared networks. If I have two enterprises or if I have two domains, can I share networks between both of them? Forwarding policies. There's an ingress policy, egress policy, there's a forwarding policy. What's a forwarding policy? How would you work with it? What's the redirect target? So these are the 5 things that I wanted to cover. I've already covered net partition. So let's come to the first this thing. So if I have an existing data center network, and that has to be, if I need to have VMs which are, on if I want to have VMs which are on the same network and I want to talk outside, right? So an existing data center network would be a VLAN based network. All of Nuage's networks are VXLAN based. So how would I do the VXLAN to VLAN based? So so our VRSG, like I talked about earlier, is the one which is actually so my VRSG is the one. If you look at the Tahoe or the Memphis or any of these topologies,
थोड़ा
बड़ा look at the Tahoe topology, right? I have VRSG, which has a set of networks called as the EXT subnet, right? So, contrary to our Helium OpenStack experience, EXT is not a single network. It's actually a set of VLANs, in which I have the floating IP subnet, and I can have any other subnet or VLAN which is existing outside, for which I want VLAN to be VXLAN. So I have an ETH here, and say the range that I have is 100 to 110, right? So there's a way, there's a set way of configuring a floating IP subnet inside here. In addition, what's happening is if I want to have a network which is, say, 101 or 102, which is not a floating IP subnet. Now remember, when I have, whenever I'm doing a floating IP thing, what I'm having internally is a NAT that's happening. Right? There's not. So the floating IP is not actually seen by the VM itself. Now, for all other communication for which I want an existing data center network, I would have to use something called as an L2 domain. Right? So the routers and the domain, analogy that we've seen earlier. A router is an L3 domain. Right? I can have two L2 subnets connected to it, and I have routing in between. Now, an L2 domain is what I would have to use whenever I have any kind of data center networks or existing networks which are outside for which I need VLAN space and traffic. So an L2 domain is defined similar to an L3 domain. And then what will happen is, so whenever I define that I am allowing VLAN say 101 here, and I'm defining that network to be part of an L2 domain, I would attach something called as a bridge port. So provider network bridge port. So there's an L2 domain here for which I attach a bridge port. Onto which I will attach my VM. Now this bridge port essentially would be attached to the L2 domain, and for all traffic which is coming in, there would be a VLAN. So remember that if you have to have provider networks, you'll have to have L2 domains, not L3, and you'll have to have bridge ports. Add something.
I actually asked that day, what exactly is the bridge port? I think explained also. What exactly it is? What kind of construct it is? Means bridge port exists within the VRSC, right?
Bridge port exists.
So is it some kind of a Linux bridge? What exactly is it?
VLAN port actually. For example, here
is it a Linux bridge? I don't know.
Linux bridge is, for example, if you hear Ajit explain that my data center has 101 VLAN.
Okay, let me rephrase my question. When it actually does the VXLAN to VLAN translation, that means it is actually stripping off some of the headers.
So when a packet is coming in,
is it a program which
it's a set of open flow rules.
Yeah.
Oh, it's a set of open flow rules.
Everything is open flow rules.
Running on like which?
Running on this. Okay, so every so before I get there, right? So every compute node, if I have a compute node, earlier what we would have, right? We would have a BR-int. यहाँ पे there would be a Linux bridge connected to a VM. यहाँ पे depending on whether I have tunnel ports or this thing, I would have a BR-ton which is connected to the right? If it's VLAN, I would have a BR-int directly. Now, all of this is replaced by something called as ALU. So all of this is gone, and I have a single open vSwitch bridge called ALU VR0, to which your end VMs are connected, and the other end is the ETH dot or whatever VLANs that I have, right? So this ALU BR0 is my VRS. So my VRS is actually an open vSwitch bridge called ALU BR0, into which all of your open flow rules are present, including this guy. This guy also has an ALU BR0. So whenever you create a bridge port, what happens is this ETH has a virtual interface called ETH0.101 which is created. And you will have all of the open flow rules that are needed for VXLAN to VLAN stripping. So what will happen is, when I have an ingress packet which is coming in, I need to add a VXLAN header. When I have an egress packet coming in from here to here, I would have to strip the VXLAN header. Right, you got that.
So which is the bridge port here?
So it's the bridge port, a port on the ALU.
Okay. What is called another confusion?
It's a logical
Open flow rules can actually strip back.
Yeah.
I thought it's just redirection.
No.
Trafficking.
No.
It can
You
modify
can
the whole
modify. You can modify the whole packet.
So
Okay.
OpenStack we will have some internal VLANs and outside we have some external VLANs. Packet will come with internal VLAN and it will be converted to some other VLAN and it will go with
In the VLC, you can actually see Bridgeport as an entity.
yes,
Yeah.
You can see that it's
That's a good question. I don't know. Is it on OVS? Does it become a port? I don't know.
there will be no new port actually. I'm thinking that ETH0.101
Might be the bridge port, yeah.
can be called as a bridge port. There will be no new port created apart from the ETH0.1.
So for every VLAN that I want to have, so for every L2 domain, I have to create a bridge port. For every L2 domain, I'll have this guy defined. E0 dot something dot x. X being the VLAN that is. And that will get added to the ALU-BR0. For all packets which are coming in this way, it's a VLAN packet. It needs to become a VXLAN packet. Yes. For all packets which are coming in this way, which needs to go out, it's a VXLAN packet, which needs to become a VLAN. All of this is via OpenFlow. So you will see OpenFlow rules here and here.
So from the UI, like how do you actually create the bridge code? What is the procedure?
Nothing, you just drag and drop an L2 domain, drag and drop a bridge code. It's a pretty simple process. The only thing is you get lost in the details.
For every, like, we have a range 100 to 110. All these alias will be created.
I mean, this question is for every provider network, 80 dot some VLAN will be created on that. It will be created. Only for VLAN, for VXLAN.
Yeah.
Anyhow, on top of that physical interface, we have a bridge. Why do we need this? This is working the way Linux bridge is working.
In Linux bridge, for every network, one bridge will be created.
For every VLAN interface,
One bridge will be created.
Here it's a single bridge.
But different ports in that bridge.
Like in open usage, we have BRS0. That is on top of it.
Yes.
That is configured as a trunk. No need to create .101.
Yes.
Is your point, why couldn't an OpenFlow rule be written to add a tag as well?
Yes.
Is that your... That's the point.
No, actually it depends upon the flows, isn't it? For example, if I want to convert VXLAN of one tag to 101, they will be writing an open flow to convert that and send to particular port. There will be some port ID for each one, isn't it?
Yeah, but it will be connected to one port of switch. You know, like S0 is directly going to one port of switch. Yeah, so it is configured as a trunk.
Yes.
Okay?
Yes.
So when packet is like from inside, in this bridge, VXLAN packet came. We have a flow that should convert to 101, 102. OpenFlow only can be converted and it will go via switch. Why we need the separate alias? Because it will be something.
The whole point of creating an alias is that your NIC would then tag the packet and then send out, right? Which can be done at the OpenFlow level also, right? I could have,
like
when I'm modifying, stripping everything, I could have added a VLAN tag.
Like a Linux bridge, because one Linux bridge has S0.101, 102, 103. Whenever packet is coming with 101, it will go via this 102, like flat network. It will work in that way. That's a confusion case.
If you have multiple physical NICs, that also can be attached to the For example,
multiple physical.
And if, I mean, for example,
the same bridge.
I mean, the VLAN of that E0 to this bridge, ALU-BR.
And who will take this here? We have to create 101, they have to create 102. One bridge is having both ports. One bridge is 0 and S1 as a physical port to that.
No.
How different will
Physical port will not be attached directly to bridge. The VLAN of physical port will be attached to this bridge.
So ideally, internally, that will be the physical one. You are telling S0 will not be attached, S0.101.
Yes.
But ideally, that will be the same thing only. Only 101 packet will go via that.
Yes.
Your question is, why isn't OpenFlow doing it?
It seems like a hard coding thing. Like packet is coming, anyhow there is an interface 101, packet will always go from there only. You are open with it.
No.
Means 101 packet will always go from there.
It depends upon the flow. The flow can be different, isn't it?
So incoming case के लिए, I mean for the incoming case, packets will either come via 101 or 102 or 103 or whatever. Now for the outgoing case, what do you do?
From outgoing case means packet is coming from VM and it is going out. So that means some packet is coming with VXLAN something. And you have a rule convert to VLAN 101. So always it will go via that H0 dot. And your OpenFlow is not that. It's something like it should go with always with this port. Ideally the rule is open.
No. That's not the thing. If I have, see when the packet is coming in from the VM to this thing, I'm going to add this thing and then So I could have a rule which would say add a tag and then send it out, or I can say send it out through this port.
Add a tag, it can go from any port. In that case, there will be no.
Right. So what I'm doing is, I could have two rules, right? I could have one rule which would say add a tag and then send it out. So it would then take any port because it's anyway tagged. Or the other way of doing it would be don't add a tag, send it out through this port, and the port takes care of adding the tag too.
What I'm feeling, if there are only 10 VLANs, if there is bunch of 100,000, so we need that many interfaces. And instead of that, means that was my question. You have 0.1 to 1000, something like that, and you have that many rules. And packet is 101, stand by this one, 102, stand by this one, 103, stand by this one. And
maybe I'm thinking that,
my question
for example, there's 80 has 100 VLANs, but Bridgeport we need also two networks. If you allow 80 there, all the 100 packets will leave the bridge, and there will be some calculation. If you allow only 80.10 and 20, only those two packets will leave the bridge. Other packets will not go to last. This is logical.
So bridge itself is containing the open flow rules. Everything is the bridge and then it is getting filled.
No, now E0 is not directly attached to the bridge. E0.10 is attached to the bridge.
Correct.
So all the packets of E0 will not go to the bridge. The E0, of VLAN 10 only will go to that bridge.
That's not allowed. If I have 1000 VLANs, then I'll have 1000 ports.
Yeah, then if config command goes to all these 1000. Some commands we are executing that level. So like you are saying at 0.10, level like 10 to 20, all these are showing there. So if we have 1000, so all these 1000.
my question, why it is not working? How open usage in OpenStack is working? That way it will be a good thing. OpenFlow itself will tag the packet and
actually why they kept that logic, maybe that design.
And that was my question. Because normally this is not just like create a VLAN interface input to you. Anyhow, OpenVSphere itself is capable to do all calculations and send it back.
My only thing is in the case where I have DVR and I have EXT on all of the compute nodes. EXT communication is happening directly with the compute node, not via the neutron node or the network node. In that case, in my Open vSwitch, do I have tagged interfaces or do I have only one interface for BREXT?
DVR.
Or in the normal case also, in my network node, for BREXT,
We have VLAN.
it's a tagged interface.
Yeah,
It's a tag interface.
It's the same fund direct.
Yeah.
But here it's a L2 domain, there it's LC domain. There we are forcefully tagging it and sending it because from BREX packet has to go out and there is only one or two, something like that. Ideally in HOS they are following it, but ideally there is no, BRX should be top of only H2 or H4 or something like that. It should not be something H4 dot.
It should be a VLAN interface, right?
No.
BREX.
Anyhow, your packet will come with one separate VLAN ID. Router can strip and send without VLAN, or it can add one more VLAN ID and send. Here we are doing it because our lab, that network is also configured in that VLAN. So we want to have a communication from this network to this network using that VLAN domain. We are tagging that packet. And BRX don't have, OpenStack will not put any rule in BRX to add a VLAN ID or just remove a VLAN ID. We have to manually go and do that. Like BRInt and BRH1, Neutron will take care to put
The implementation in Helion and upstream OpenStack is the same.
Yeah, it's up to BREX, we are only configuring. It's not coming from OpenStack. We are configuring BREX. We are deciding the port like it's 0 or it's 0.141.
The virtual port is being created, right?
We are deciding.
ETH1.101 is getting created.
That we are deciding. But the BRH2, whatever is in compute node or BRInt, that is configured by a Neutron. Like whenever one network is created, this guy will put OpenFlow rule in BRH1 conversion. But for BREX, there is no rule. Like there is no putting of VLAN ID or removing of VLAN ID. And we have to take care of that. For VRS, that guy will not do anything.
I think
Maybe they thought that many VLAN IDs will not be there.
see this is the same way floating IPs also. Floating IPs also have seen.
Floating IP is
Wait.
no, in this.
So there are two ways. One is this, other is that one.
Okay, let's proceed.
Yeah, so floating IP